What's up, Chem peeps? Who is ready for some free response? Stoichiometry style. Sulfuric acid, H2SO4, can be prepared commercially from elemental sulfur. In a typical sequence of reactions, the sulfur is first burned in oxygen gas. The SO2 is then converted to SO3 using a catalyst. The resulting SO3 is reacted with water to produce the desired product, H2SO4. Part A. If 64.0 grams of sulfur is mixed with 4.0 moles of oxygen gas, identify the limiting reactant. Justify your response using a dimensional analysis calculation. Dimensional analysis. Alright, we've got 64.0 grams of sulfur mixed with 4.0 moles of oxygen. We're trying to identify the limiting reactant. I'm going to have a series of reactions here. The reaction that includes sulfur and oxygen is that first reaction. So I'm going to start with the 64.0 grams of sulfur. And I need to think about, if I used up all 64.0 grams of sulfur, how much SO2 would I make? My first step, convert my mass in grams to moles. My molar mass here coming from the periodic table. Next, I'm going to compare moles of sulfur to moles of SO2. That relationship is coming from my balanced chemical equation, and it's a 1-to-1 relationship. Boom. So let's think about how many moles of SO2 I would potentially make if all 64.0 grams of sulfur reacted. 64.0 times 1 answer divided by 32.06 answer times 1 answer divided by 1 answer. To 3 sig figs, I would make 2.00 moles of SO2. Potentially, if all of that reacted. Now let's think about how many moles of SO2 we could potentially make if we had 4 moles of oxygen gas. When I set up my dimensional analysis, notice that this time it's going to take one less step, because I'm already provided the number of moles of oxygen. My relationship between moles SO2 and moles O2 comes from my balanced chemical equation, again 1-to-1. I don't even need a calculator for this one. If I have 4 moles of O2 and it all gets used up, I could potentially make 4.00 moles SO2. Now the question becomes, which reactant, my 64 grams of sulfur or 4 moles of oxygen gas, is going to limit the amount of product that I can make? Look at our two calculations. Notice that 64 grams of sulfur could only make 2 moles of SO2, while 4 moles of oxygen could make 4 moles of SO2. The limiting reactant is the one that limits how much product can be made. In this case, the 64 grams of sulfur. Sulfur is the limiting reactant. It limits the amount of SO2 that can be produced. Moving on, subpart I. Calculate the theoretical number of moles of sulfuric acid that was produced. You must show a numerical setup using dimensional analysis. Dimensional analysis to receive credit. Alright, now importantly, in part A, we identified that sulfur was our limiting reactant. So as I go back up to this series of reactions, it's the sulfur that's going to ultimately determine how much SO2 I can make. And then in the second equation, we'll determine how much SO3 I can make. And in the final equation, we'll determine how much H2SO4 I can make. So remember, anytime you're working through a stoichiometry calculation in which you're provided with amounts for 2 reactants, you want to identify the limiting reactant and start with that amount. Now our limiting reactant is 64 grams of sulfur. First thing I'm going to do is convert that to moles. Boom. Next, let's convert that to moles of SO2. Boom. So I'm just recycling what I did in part A. So at this point in my calculation, I've taken my number of grams of sulfur and converted it to moles of SO2. Once I know how many moles of SO2 I made, I can figure out how many moles of SO3 I will make from the second reaction. Boom. A 2-to-2 relationship. From there, once I know how many moles of SO3 I'm going to make, I'll determine how many moles of H2SO4 I will finally end up with. Boom, a 1-to-1 relationship. Quick jump to my calculator. 64.0 times 1 answer divided by 32.06 answer. Pause, stop and think about this. My 64 grams of sulfur essentially means that I've got 2 moles of sulfur. So I'm starting with 2 moles of sulfur that's going to completely react in excess oxygen. Moving back to the dimensional analysis. Times 1 answer divided by 1 answer. Back to my equation. If I started with 2 moles and it completely reacts, I'm going to make 2 moles of SO2. Back to my dimensional analysis. Times 2, answer, divide by 2, answer. Let's take a look at our series of reactions. If I made 2 moles of SO2 in my initial equation, and I react it again with some oxygen using a catalyst, I will make 2 moles of SO3. Again, because the ratio between SO2 and SO3 is 2 to 2, or 1 to 1. However much SO2 I start with is how much SO3 I'm going to end up with. Back to my dimensional analysis. Times 1, answer, divide by 1, answer. Take a quick peek back at my series of reactions. If I then have made 2 moles of SO3, and it completely reacts, I'm going to form 2 moles of H2SO4. Again, because the ratio between my SO3 and H2SO4 is 1 to 1. So however many moles of SO3 that I have, I'll make the same number of moles of H2SO4. So to finalize this, to the correct number of sig figs, I'll make 2.00 moles H2SO4. Boom. Part B. Sulfuric acid can be neutralized by sodium hydroxide, a base. Write a balanced chemical equation that describes the acid-base neutralization reaction of sulfuric acid, H2SO4, with sodium hydroxide. Alright, we're reacting H2SO4 with sodium hydroxide. Now my products here, I have to remember that acid-base neutralization reactions are examples of double replacement reactions. Recall that the hydrogen from the acid and the hydroxide from the base are going to come together to form water, and then the sodium or the cation from the base and the anion from the acid are going to come together and form our salt. In this case, sodium sulfate. Don't forget your nomenclature. Now that we've got our formulas correct, let's balance this. I need a coefficient of 2 here to balance out my sodium, and then a coefficient of 2 here to balance out my hydrogen and my oxygen. Done. Subpart I. Calculate the theoretical number of grams of the salt that could be produced in the acid-base neutralization reaction from the amount of sulfuric acid calculated in A part I. You must show a numerical setup using dimensional analysis to receive credit. Dimensional analysis. Alright, let's go back up to A subpart I and think about how many moles of H2SO4 we came up with. 2.00 moles H2SO4. Boom. Let's compare moles H2SO4 to moles of our salt, sodium sulfate. The relationship based on our balanced chemical equation is a 1-to-1 relationship. So if I neutralize all 2 moles of this sulfuric acid, I'm going to make 2 moles of sodium sulfate. But be careful because it wants grams. Here I'm going to use the molar mass of sodium sulfate, which comes from adding together the mass of 2 sodiums, 1 sulfur, and 4 oxygen. Boom. Quick trip to the calculator. 2.00 times 1 answer divided by 1 answer times 142.04 answer. We're going to make 284.08 grams of sodium sulfate. Boom. This is my theoretical amount of sodium sulfate that I could make if all 2.00 moles of sulfuric acid reacted. Subpart II. If the actual number of grams of the salt produced was 213 grams, what is the percent yield for the acid-base neutralization reaction of sulfuric acid with sodium hydroxide? Alright, let's recall that percent yield is equal to actual over theoretical times 100. We're told in the question that we produced 213 grams of the salt, but theoretically, we should have made 284.0. Whoa, my sig figs here are crazy out of control. Be 284 to the correct number of sig figs. So theoretically, I should have 284 grams. Actual over theoretical times 100. 213 divided by 284 answer times 100 answer. We've got a 75% yield. Boom. Done. 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 Done.